Hey everyone, and welcome to the video. My name is Dwayne, and today we're diving into one of Aurelia 2's most powerful and underutilized features, and that is AppTasks. So AppTasks let you hook into Aurelia's application lifecycle, and they allow you to run code at key moments like app startup, shutdown, and then other little moments during the lifecycle of an Aurelia app spinning up and eventually rendering your beautiful app full of components and initialize plugins and all that kind of stuff. So these hooks empower you to initialize services, load dynamic features, configure dependencies, clean things up, register analytics, calls, set up state management, all that kind of stuff, but at a framework-wide level beyond what component lifecycle hooks can do. Because I know there is some confusion between what is the difference between an app task and a component lifecycle, because they both kind of take the approach of life cycles, but as you'll see, they are very much different and do different things. So in this video, we'll take a complete look at what app tasks are. We're going to break them down, each of the 7 lifecycle slots, and kind of explore what they do and when you might use them, and then show you some examples of how these might be leveraged as well. So by the end of this video, as an application developer, especially as a plugin developer, you'll have a better understanding of how to use app tasks to improve modularity, performance, maintenance, and whether or not you even need to use app tasks, because sometimes you have to use the right tool for the right job, right? And sometimes app tasks maybe aren't what you need, and hopefully this clears that up. Let's dive into the first part of this video and kind of go over some things that we just talked about briefly, but it's important, and it's what are app tasks and why would you use them? App tasks are framework level lifecycle hooks, and they allow you to write code that runs across the entire app lifecycle. So if you've worked with the component lifecycle hooks before, so for example, attached, binding, unbinding, etc., app tasks are actually a step above that. So they're not the same as component lifecycle hooks, and they kind of get run at different points of Aurelia's lifecycle. So they're designed for app-wide tasks like dependency injection, initial data loading, background job setup. If you have an analytics plugin, maybe you want to set that up, etc. They're really good sort of framework level hooks, not component level hooks. So why use app tasks instead of a component lifecycle hook? And it's a really good question, because sometimes a component lifecycle hook is what you want. If you want something to execute inside of a component, you want to keep it isolated, say a jQuery plugin, or you want to fetch some data that's being displayed in that particular component, then a component lifecycle hook might be what you're after here. But the reason to use app tasks is, firstly, they run in the global scope, so they impact the entire application, and they operate independently of any specific component. So it doesn't matter how complex your application is, how many components you have, how deep the hierarchy of your parent-child relationship with the components are. It doesn't matter. It's always running at that top level. Second is pre-root initialization. So some operations, for example, dynamic resource registration, they must occur before Aurelia's root component is created. And this allows you to run code effectively before any component is even loaded by Aurelia. So at a really top level. They also allow for framework behavior control. They let you inject yourself into the compiler and DI container lifecycle, so you can run stuff before things have been rendered, before the DI has pulled in the resources and kind of determined everything that it needs. They're really, really powerful in that aspect. And lastly, proper cleanup. So with app tasks, you can clean up resources when your app shuts down, like disconnecting WebSockets or saving transient state. Basically anything when you want to know when the whole app is turning off, these allow you to do that. So think of app tasks as the bridge between Aurelia's framework, core level APIs and lifecycles, and your app behavior. So now we've got that out of the way, we're going to actually go into the individual lifecycle slots. So AppTasks consist of 7 lifecycle slots, and they correspond to a specific phase of the startup or shutdown process in your Aurelia application. So we're going to go deeper into each one. We're going to explain where it fits, and then kind of, see where you might end up using that particular application task in your application. So the first one is the creating app task, and this runs right before Aurelia creates the root component. It's the earliest lifecycle slot, and it's your last chance to register resources in the DI container or perform pre-startup tasks, critical to your app. If you're working in things like global error handlers, environment configuration files, or third-party initialization, this is the best spot for it. So I'm going to show you inside of our main.ts, I've initialized an app here that I'd used npx makes Aurelia. So I did this, and then I chose TypeScript and Vite for the bundler, but that's pretty much it. You can see the structure down here is what you would get if you ran that scaffolding command. So on the left here, we've got a few. We've got main.ts, and then my app, which is our root component that displays hello world, and main.ts is our bootstrap file. So an application task is passed into the register method. So if you've registered plugins or anything like that in Aurelia before, you would be familiar with this process here of basically passing things into register. So I'm just going to quickly show you. I'm going to import AppTask and go creating, and then we're just going to pass in a callback function to that. And then inside of this, we're just going to go, thank you, AI autocomplete. And we're actually missing something very crucial here, my bad. We have to pass it into register, as you can see. So if we were to run this app now, we've got hello world here. And if you look in the console, we can see AppTask creating, configuration loaded and registered. We didn't actually load anything, but inside of here, this is really cool feature about application tasks is they can be async. So you can actually also inject things like the container and stuff like that to perform, registration of various things and whatnot. So a really good example here is you might pass in the container. So iContainer, and then you would make that async. And then inside of here, you would go, pretty much something like this. This is an example of calling an endpoint. So your API might be like config. That would get you your JSON config there. And then you may have like a configuration provider or something like that in there. So const provider. And then we'd go container.get. And then app configuration here, which would probably be like a dependency in your application. And then inside of that, you would probably go provider, with settings. That would work. So this is an example of before anything happens in your framework, in your application, this hook is going to run first. So we can actually put in, to highlight this, we can actually put in a delay, promise delay, and then do that. And then we're going to make it wait 3 seconds here. So we're going to go here. We can see there's nothing. And then it waited. So you can see it actually halts the loading of the root component until that's happened. So the really powerful thing about this is that this allows you to set things up. This is the point where you want, like, your app can't render until you've done whatever you're doing in here. So maybe feature flags is a really good example. You may set some things up in there, load some configuration options. To kind of reiterate what we've done here, this example is replicating, dynamically fetching a configuration file and then registering the settings with a provider or whatever. making sure that the app is properly configured before the root component is created. So that's a really powerful one there. And as you can see, you can call this a couple of different ways. We'll touch upon that a little bit later, but you don't always have to pass in dependencies, because you can actually just pass in a callback as well that has no arguments in there. But we're going to move on now to our second hook. So our second hook is hydrating. So hydrating runs right after the root controller is instantiated, but before the view is fully compiled. This is a great place to set up runtime configurations, routing metadata, plugins, basically anything you can kind of think of. So a good example here is, say for example, we've got AppTasks and we'll go hydrating. And we may want to inject something. So my plugin service, and then plugin service. And then we would probably call, in this instance, initialize. So obviously my plugin service does not exist in this example. This is a really good point to kind of initialize things and perform all that other kind of stuff. And as you can see, we are passing in this dependency, which makes it available on this callback here. So just dependency injection, basically, and pretty similar to the creating hook that we just did above. It just runs a little bit later, but still a good place to set some things up. So in that example, we were pretending to initialize our plugin service while the root controller is being prepared. And it's really useful if something like routing or dependency injection depends on a plugin working correctly. Maybe your plugin's crucial to your app. That's where you would do it. So we're going to move on to the third hook now, and that is hydrated. So hydrated runs after the root controller is hydrated, but before its child elements are hydrated. So this is a perfect place for global telemetry, analytics tracking, or any other task you want to run right after the root is fully prepared. For example, say you wanted to set up some telemetry stuff in here, you would go apptask.hydrated, and then you might inject your service in here. And then obviously this dependency does not exist here. But if we were to actually make that a dependency, we could actually see this taking place in here. So we're going to look in here and we can see our service has started, and you can see that is being called from this start method here. So this injected this class into our hydrated application task here. And you could do this for other things as well, like Google Analytics or other things like that, WebSockets, whatever you want, basically. In this example, it's ensuring that it's only starting after the application itself is fully hydrated and ready to run. It's a pretty nifty little application task we got there too. Now, onto our fourth one. Our fourth one is the activating application task. Now, this runs before the root component is fully activated. Think of it as the precursor to the app being ready, essentially. This phase is where the data binding engine begins, and it's a great spot to load application-wide state and perform async tasks that must finish before the app starts running. For example, if you're not using the Aurelia state plugin, maybe you've got something else going on in there, you would go apptask.activating, and then maybe global state service, and then async global state service, and then load state. And then we're going to create that fake global state service as well. And we're going to go async for that method, and then put a delay in there as well. So I'm just going to delete this import too. Okay. So you can see it is still halting the rendering of the app because we've made it async in there. But if you were to take the async out and just call it by itself, it's not going to make the app wait for anything in there. It's just going to fire. Once again, you can see the app waits for the global state service to initialize completely before letting the app fully boot. Once again, so far these 4 app tasks that we've shown you, if you make them async, they are going to delay the rendering of your app. And that's a really important thing to remember. For our 5th one, we're going to look at the activated application task. So activated runs after the app is fully running if the name wasn't obvious enough already. And this is where you perform app startup tasks like enabling analytics tracking, starting background jobs, or sending metrics. So basically, you know the app is all set up, nothing's gone wrong, it's happy days. We can actually go AppTask.activated, and then we may pass in an analytics service into that. And we can also make this async as well, just to kind of show you the behavior of what's going to happen here. But you're going to notice something here as well. So if we put that delay in there, you'll notice that it doesn't delay the execution of the app, because from the activated hook onwards, it's not going to affect the rendering of your app, because activated means the app is already all set up and ready to go. It's just running at that particular point. It's really good lifecycle hook to do stuff that may need to interact with the page or set a class on the body or something like that. Basically, whatever you can think of pretty much after the app is run, that's going to happen there. We're going to go on to our final 2 now, 6 and 7, which are kind of very similar to one another. Number 6 is deactivating. So deactivating runs right before the application begins teardown. And this is the phase to prepare for clean shutdowns, like saving state, closing connections, like WebSockets or whatever, all that kind of stuff. Once again, you're probably starting to see the pattern here. It's AppTask.deactivating. And then you may have like a WebSocket manager class, and then disconnect. So you're not going to see anything in the console, obviously, here, because we're not shutting the app down, but it's a really good spot to start cleaning things up and beginning to clean things up. Pretty self-explanatory, not a whole lot to explain on that one. Now, a final one, as I say, is pretty similar to deactivating, and that is deactivated. So think of it like in a component, you have detaching and then detached. So deactivated runs right after the app is fully shut down. And you can use this phase for tasks like cleaning temp files, clearing app state, maybe clearing local storage, deleting cookies or whatever. That's where you would do it. And once again, there's nothing really to show here other than you can call deactivated and then console log in there. And obviously, if we go into our app, that's not going to do anything because the app has not shut down. That's all 7 of the app tasks in there. And as you can see, they're really easy to work with. If you're using TypeScript, they're going to show you the definitions of them. And there's a couple of ways that you can use them. Without going back over them again, we're going to show you the different ways of working with app tasks. You can use it as just a simple callback with no arguments here. You can see that we've got that. But you can also do this. You can go apptask.creating and then we're going to inject the container. Pardon the errors in the typing here in the autocomplete. But basically, you can see that we'll do the delay. 3 seconds. And we'll make that async creating. So you can see you can actually call the same task multiple times. You probably wouldn't, to be honest with you, like what we're doing here. But this is just highlighting that you can actually pass in a dependency to get registered with the dependency injection container and then reference that. So passing it in here is going to make it available here. And it's not just the container, like what we're injecting here. You can also inject the router from the router package in there as well. And you would have seen before when we were doing our examples that we're injecting things like analytics services and all that kind of stuff. So you can see, look, we've injected the router in here and we've got all the kind of stuff that you would normally get if you injected the router elsewhere. And that goes for anything else in Aurelia or in your application. So no arguments, an empty argument callback in here. We may want to do something, or an async callback. Now, once again, this doesn't need to be async either. It's worth pointing out. If I go in here and delete all this, you're going to see that I'm still getting the router in here. It does not have to be async. It can, but async means that if you're going to run the first few app tasks, you're going to delay the rendering of your application. So that's really important to remember that you can delay that execution of your UI on there. Now let's talk about best practices real quick. We're not going to delve into that too much because it's pretty self-explanatory, I think, but the obvious one is picking the right lifecycle slot. Use creating, for example, for setup, activating for state loading or loading data or whatever you need, and then use deactivating for cleaning up. It's just common sense. If you've worked with Aurelia before, you would be well aware of that. There's all these lifecycle hooks in there, and it's really encouraged to clean up after yourself so you don't have memory leaks and all that other icky stuff in there that can come from just leaving things hanging around. The second one is minimize blocking tasks. We have talked about this a few times, and I talked about this just before, but you should keep your tasks fast and light. So try not to make them too heavy and do too much. And if you're going to make them async, just be aware of that the first few. So the first 4, so that's creating, that's hydrating, that's hydrated, and activating. If those are async, you're going to block your UI from loading. So it's really, really important that you remember that point, because if something goes wrong and your app doesn't render, it's possible you could get yourself into a little mess there where you don't realize your app task is failing or an API request is failing or something like that. But on top of that, it's also important to keep your app tasks nice and simple. Try not to do too much in them. Make them, small and light. It's just good kind of like architecture basically, and something that you would do inside your components. Another important one from a best practice perspective is avoid cross lifecycle dependencies. Tasks in one slot should avoid tightly coupling logic to another slot. These are all individual tasks. They should be treated separately to one another. Nothing should rely on any other tasks doing anything, except maybe for really rare circumstances where you need to set up some configuration options, and then in a later task, you may need to access those. But there are very few scenarios where you would want them to kind of be dependent on each other. Ideally, you want them to just be these separate independent things in there, basically. That concludes the video. As you can see, they're not too difficult to work with. They're nice and powerful. And most importantly, they are different to component lifecycle hooks. To recap, AppTasks provide Aurelia's lifecycle hooks to handle application-wide setups, so configurations and cleanups. And it's pretty versatile. It's easy to work with, whether you're registering late dependencies, loading state, initializing plugins, or cleaning up WebSocket connections. You can see there's a task pretty much for everything that you need. I highly encourage you to experiment with these lifecycle slots in your projects. because as you can see, they're not very difficult to implement. So yeah, play around with them and let us know how you're using them, especially if you're a plugin author. And if you look through some of the Aurelia plugins, you'll actually see that AppTasks are being used like core framework packages as well. For example, the routers, using them to set some things up. I know that, and a few other instances. So definitely look through the Aurelia repository as well and search AppTask and see how they're being used. That concludes the end of the video. Thank you for watching. If you're interested in seeing more deep dives, or if this is a topic that you would like to see us talk about, please let us know, because we're happily want to make content for the community and what you want to see and what you're interested in learning. So definitely don't be shy in letting us know. And hopefully we'll see you around in the next video. Thank you very much.